This is a still image of M-Mode Echocardiogram. M-Mode is time motion mode. The horizontal axis is time, vertical axis is distance from the transducer. That is M-Mode, one of the older modes currently used mainly for taking left ventricular measurements. In the inset, you can see the two-dimensional image, location of the transducer here in the parasternal region. This is the parasternal long axis view, right ventricular outflow tract, left ventricle, left atrium, aorta, aortic valve, mitral valve. These are the things you are seeing in that inset image. This is movement of the anterior wall of the right ventricle, movement of septum, interventricular septum, movement of posterior wall of the left ventricle. Here you can see that the systolic contractions are lesser. That is why it is a case of left ventricular dysfunction with ejection fraction of 35%. If left ventricular ejection fraction is normal, in systole it will come more into the cavity. These two walls will approximate more to each other when the left ventricular function is good. Here you can see that the left ventricular function is poor. LVIDs means internal diameter of the left ventricle in systole. LVIDd means internal diameter of the left ventricle in diastole. LVPWd is thickness of the posterior wall in diastole. IVSd is thickness of interventricular septum in diastole. And EDV and diastolic volume. IVS by LVPW is the ratio between the thickness of these two. Here it is 1. And in cases like asymmetric septal hypertrophy or hypertrophic cardiomyopathy, there will be disproportionate thickening of the septum. ESV is end-systolic volume. FS is fractional shortening. How we actually take the measurement is you mark out the anterior region of the interventricular septum, posterior region of the interventricular septum, anterior region of posterior wall, and posterior region of posterior wall. This is in diastole. Corresponding measurements are also made in systole. Computer program of the echocardiograph automatically calculates the measured values.